Next in our list of skills is looking at how to solve multi-step real-world problems. So these are ones where you have to do a little bit of thinking in order to do some more thinking, or solve for one piece of information in order to get to your final answer. So looking at the homework as our models, we know Jennifer had a bag of rice. She cooked an equal amount of rice each day. After 2 days, she was left with 4/5 of the bag of rice. After another 5 days, she was left with 6 kilograms of rice. Draw a model to show this problem. So thinking about some previous videos where we talked about characteristics of real-world division problems, I'm going to begin by thinking about what do I have, or the total, and do we know our amount in each, and then do we know our number of groups? And in this situation, we know our groups are going to be days. That's how things are broken up into. So we know that Jen has 1 bag of rice of an unknown kilograms. We know that each day she cooked an equal amount, and that after 2 days she was left with 4/5 of a bag of rice. So 2 days left with, and we need to know, we do know some amounts of groups or days. So we have 2 and we have 5. And so looking at how we can organize all this information is going to be probably the best option, just to be certain. You might be able to kind of guess and figure your way out, but having a visual to look back on is really, really quite nice. So if we start out, we know we have 1 bag of rice, and I'm choosing to do one big bar model rather than multiple small ones, just because we're starting out with a single bag. So we know she cooked equal amounts of rice each day, and after 2 days, she was left with 4/5 of a bag of rice. So I'm going to show fifths here because we know this is how much she was left with, and that this was 2 days. So in this, I'm going to shade that out with red because we got rid of that. So 2 days there. After another 5 days, she was left with 6 kilograms of rice. Draw a model to show this problem. Well, I don't like how those are overlapped. Let me try one more time. So, that's not the highlighter. So first, before we can get too far into this, we are going to have to look and see, can we figure out, since 5 is odd and 2 is even, I mean, if this was after another 6 days, it would be really easy. We could just shade in another 3 more of those fifths, because it looks like in 2 days, Jen used 1/5 of the bag. And so that means in 4 days, she's going to use 2/5. So let's see if we can figure out, based on 2 days, can we figure out how much is used for 1 day? And so we know this is a half of the amount of time. So we need to take 1/5 and we need to divide it by 2, because we want to figure out if we had that over 2 days, what would we get? And we could show this on our bar model by breaking this up. If there's 2 days inside of this one, it looks like each one of those days is going to have used 1/10. And if we do this math here, we know that this is equal to 1/5 times the reciprocal, which is 1/2, and that equals 1/10. So the math backs that up. So we know that each day she uses 1/10 of the bag of rice. And I don't know why my iPad keeps doing those lines. Like that. Okay. So now all we have to do, let's shade in with a different color for the 5 days. So here's 1 day, 2 days, 3 days, 4 days, 5 days, right there. And I'll write that with that color so I can show this. Here's 5 days. And then we also know, I'm going to pick blue, we haven't used blue yet, that after those 5 days, she was left with 6 kilograms. So this was the amount remaining. So here, this is 6 kilograms remaining. So now that we have all of that picture, all of that information organized, we drew a bar model. It shows 1 bag of rice. And we don't know how much that bag of rice weighed, but we do know a lot of information. 2 days, she used 1/4 or 1/5 of it, which ended up being 1/10 for each day. Over the course of 5 days, she used 5/10 of it, and then we were left with some of that remaining. So based on that picture and based on our calculations, it looks like for question number 2, how much rice was there in the bag at first? I'm going to start with my sentence. At first, there was blank kilograms rice. So let's do some calculations to get there. So we know that the last 3 chunks are 6 kilograms. So 3/10 is 6 kilograms. So we could figure out how much is in each one of those. If we look for this amount right here, then we would be able to figure out how much was left. So if 3/10 is 6 kilograms, we have the 6 kilograms, and we're dividing it up into 3/10. Is that right? Let's see. 6. Let's do 6 divided by 3, because that's going to be how many groups we have, and that equals 2. So if we erase these question marks up here, we know that in those 3 groups, there are 2 kilograms each, and so that does mean that there were 6 kilograms remaining. So let's do 2 times 10, and we would get 20. So at first, there were 20 kilograms of rice. And if we write this 2 in each of these, 2, 4, 6, 8, 10, 12, 14 plus those 6, that would get us our 20 kilograms. So let's look at another problem to see if we could dig this apart. Robert bought 1 1/4 kilograms of meat on Monday, another 1 1/8 kilograms of meat on Tuesday. He cooked 1 5/8 kilograms of the meat he bought and then divided the rest into 1/8 kilogram portions. Draw a model to show this problem. So you could do 2. I'm going to show both models, either multiple small bars or one big bar that contains all of this information. So we know first that we have Monday and Tuesday. And so on Monday, he bought, I want my blue back. Come here, blue. He bought 1 1/4 kilograms of meat. And then on Tuesday, he bought 1 1/8. So I'm going to make this one just a little bit shorter because I know 1 1/8 is a little bit less. Then we know that he cooked 1 5/8 kilograms of the meat he bought and divided that rest into those portions. So that means if we were to combine this with purple, combined that total, he cooked 1 5/8 of it, and whatever was left, he broke that into 1/8 kilograms. Now, as you can see, 2 bar models on this one seems really less than ideal because you have a lot of information that doesn't quite fit very well. So I'm going to quick shrink this down and look at, well, if that doesn't work and gets confusing, what if we just do 1 big bar? So here is all of the meat that Robert bought. And on Monday, he bought 1 1/4 kilograms. And then on Tuesday, he bought 1 1/8. And then we know he cooked purple amount. So he cooked 1 5/8, which is going to be, we know it's a little bit more like up to here-ish, cooked here-ish. And then we know that he divided up this remaining bit into 1/8 chunks. And so that is the information we know. So looking at this one big bar does seem to be a little bit easier for me to visualize all of this. And it's the same information, it's just shown a little bit differently. I am going to change this to orange to match our groups there. So here we have our model. It shows the meat. It shows how much he bought each day, shows some that he cooked, and then shows some that he divided up. So let's see. Oh, come back. Uh-oh. It went away. I don't know where it went. That's wild. Let me try tapping out of that. What happened to my background? Tap out, tap in. Okay, now it's back. That's wild. Sorry about that. So our question is, how many of those 1/8 kilogram portions are there? So we want to know how many of these. So working backwards, we know that if we're looking here, we need to figure out this piece of information before we can divide that into 1/8. So we have to learn that, we need to know what is our total amount of meat so we can subtract what we cooked. So we need to add 1 1/4 plus 1 1/8, which is going to be 2 1/4 plus 1/8. I just added those whole numbers. I know 2 1/4 is equivalent to 2 2/8. Plus that 1/8, we get 2 3/8. So that's how much he has, 2 3/8, 2 3/8. And now, next step, he cooked a portion of that. So we have 2 3/8, cooking a portion, 1 5/8 kilograms. Now we have to subtract. So I'm going to subtract my whole numbers. 2 minus 1 is 1. So I'm left with 1 3/8 minus 5/8. I'm sorry for those lines. I don't know why they happen. And so I know this 5/8 is really a 3/8 and a 2/8. And that 1 3/8 minus 3/8 is 1. So I'm left with 1 minus 2/8. And again, I'm thinking of this as an 8/8 minus 2/8 with some random fireworks there. And 8/8 minus 2/8 equals 6/8. Those are both even, so I am going to simplify. And we are left with 3/4. So the amount of meat that was remaining was 3/4 of a kilogram. All right, we're getting closer. We are to our final step now, where we just need to figure out how many 1/8 are in 3 fireworks, 3/4. That to me sounds like division. 3/4 divided by 1/8. So let's multiply by the reciprocal. 3/4 times 8/1. I am going to simplify by dividing by 4. And rewrite with some fireworks again. Looks like I need to restart my iPad. But we are left with 3/1 times 2/1, which is equal to 6. So there were 6 1/8 kilogram portions. Boom. So with these problems, starting out and sometimes maybe looking at which, if I tried using multiple small bars and if that gets messy, maybe I'm going to take a moment to draw the bigger one. So that way you can see what work you need to do. Because remember, the value of bar models is that sometimes they tell you, I'm going to add a page so I can put this in writing. So bar models, they can either do two things. They can either show you the answer, or they can show you how to find the answer. They clue you into what math do you need to do, or they clue you into your missing info you need to find so you can answer the problem. with fireworks. That's so exciting. All right. Thank you very much.